Hello everyone, today we are going to discuss about Laplace transform. Before we start, let me first give you a quick definition about Laplace transform. Laplace transform converts the function of time or f of t to the function of complex variable or f of s. It is useful in solving linear ODE. It is also conversion of calculus to algebra. Before we start solving some examples, we must first identify the value of f of t, which corresponds to the value of f of s. Here are the chart of the value of f of t, which corresponds to f of s. Let's start solving some examples. F of t is equal to 5, with 5 being the constant. We can solve this with the use of number 1 in our chart. So f of s now is equal to 5, which is the constant, over s. Next, f of t is equal to e raised to 6t, with 6 being the constant. We can now solve this with the use of number 2 in our chart. F of s now is equal to 1 over s minus 6 is our constant, so s minus 6. Next, f of t is equal to t squared, with 2 being the constant. We can solve this with the use of number 3 in our chart. F of s now is equal to n factorial. N corresponds to the constant, so 2 factorial over s raised to 2 plus 1 is equal to, the value of 2 factorial is 2 over s cubed. Next, f of t is equal to sine 4t, with 4 being the constant. We can now solve this with the help of number 4 in our chart. So, f of s is equal to w, which corresponds to the constant, 4 over s squared plus 4 squared. Simplify the equation, so 4 over s squared plus 16. Last, f of t is equal to 2 hyperbolic sine 3t. We can solve this by first separating number 2. F of s now is equal to 2, and solve this with the use of number 7 in our chart. 2 s over s squared minus w squared, our constant is 3, so 3 squared is equal to 2s over s squared minus 9. We are now done with the basic principle of Laplace transform. Let's move on to inverse Laplace transform. In inverse Laplace transform, we are just going to do the reverse of what we have done a while ago. So instead of converting f of t to f of s, we are going to convert f of s to f of t. Here are some examples. F of s is equal to f of s equal to 3 over s minus 4. First, we are going to separate 3, the numerator, from the equation. F of t now is equal to 3, 1 over s minus 4. And with this, you can see that this equation is the same as the number 2 in our chart. So, we can easily solve this by 3 e raised to 4t. Next, f of s is equal to 6 over s raised to 4. We can now solve this with the use of number 3 in our chart. So f of t now is equal to 6, which is equal to 3 factorial over s raised to 3 minus 1 is equal to t raised to 3. Next, f of s is equal to 3 over s squared minus 9. We can solve this with the use of number 6 in our chart. So 3 is the constant. So w represents the constant in our equation. W over s squared minus w squared is equal to hyperbolic sine 3t. Now we are going to solve something a bit more difficult. F of s is equal to s plus 2 over s squared plus 4. In here, you can see that you cannot easily solve this without separating the equation in the numerator. So f of t now is equal to s over s squared plus 4 plus 2 over s squared plus 4. With this, you can easily know that this 2 can be found in our chart. So f of t now is equal to, in the first equation, you are going to use number 5 in our chart. Cosine 2t. It became 2 because the square root of 4 is 2. Plus, the second equation, we are going to use the number 4 in our chart, which is w over s squared plus w squared. W represents the constant. This will now be sine 2t.